For us, it's time to move on to the next speaker, Michael Heinrich from University College of London. Thanks for coming and being with us today. You're a professor at the University College of London. You started your academic journey by a master's in anthropology at Wayne State University. Then you moved on to a master's degree in biology and to field studies on medicinal plants with a Mexican Indian group. And your research today has a strong global focus on fast-changing global health needs, and you're tackling questions including the value chain of herbal medicine and the impact of climate change on the sector. So, ladies and gentlemen, dear daylighting, dear audience, dear community of the DLA, please put your hands together to welcome Michael Heinrich. The floor is yours.
Thank you very much. Thank you very much for the kind words and reminding me of things a long time ago, like Wayne State University in Michigan, and maybe not so much light in the city center of a very poor city. But let's go right to what we are doing today. I really appreciate the invitation to present a result or present some of the results which are the outcome of a collaborative project between Caroline Marker and her team at the University of Zurich and my group at the UCL School of Pharmacy. Right, while we are getting these things going, I just want to highlight the project is, here we are, now we are one ahead. This project is a collaboration between some experts in photodynamic therapy and us as a group working on ethnopharmacology, the study of traditional medicinal plants, phytochemistry, and pharmacy more general. I should also point out that part of this research is the PhD thesis of Dr. Lin-Ru Mu, who just finished her PhD basically today by submitting in her revisions, and she was not funded by the Velox Foundation. She was a self-funded PhD student with me. Right, what are we doing today? I'm giving you a little bit of an overview here, what the scientific questions is, and what we did, plus some of the experimental design questions, and a short outlook. Now, as I said earlier, the idea here is what I hope and still think is very innovative. Lots of people have worked on medicinal plants and possible effects on wound healings. If you go into any ethnopharmacology journal, you see lots of studies, mostly on mice. They're pretty horrific studies, and many of them are with multi-herbal preparations. At the same time, there obviously is a lot of work on photodynamic therapy, and we have seen a few examples, mostly in the context of wounds. Mostly in the context of cancer. We brought this together in the context of wounds. Now, why wounds? What are the core questions here? Wounds are a major health challenge globally. And they are a neglected disease in a double sense. On the one hand, there's very little going on to improve the situation, especially on a development side. At the same time, it is a disease which is not recorded as a neglected disease, because neglected diseases are infectious diseases. So our idea really is, can visible light exposure alter the cellular effect of plant extract producing light-dependent or treatment light interactions? And then we want to look at some chemical aspects, and that's what I'm taking you through today. So I'll keep this very short, but basically the project has three elements. One is obviously the light source. The other one is the absorption of a molecule within a plant, and then the molecular oxygen which is generated. So bringing these together will enable, and that's empirically proven with other substances, enable wound treatment, including, obviously, the treatment of infections. This is a short mechanistic summary. Most people here now work on isolated compounds, isolated metabolites, which is a perfectly suitable and important approach, but has the disadvantage it may not be useful, for example, under difficult socioeconomic conditions. The mechanism of action is summarized here. You see something which we have heard about earlier, but ultimately, again, we see reactive oxygen generated, and this depends a lot on the specific molecules. Now, the question we are asking is, okay, there are so many plants used traditionally in the treatment of wounds. In my own research and in the research of my students, we have again and again seen that the topical treatment of skin diseases, infections, but also wounds, is the main area of traditional medicine, together with gastrointestinal conditions, and today, I should add, conditions like diabetes. So how can these two elements be brought together? Now, the first part we did is actually looking at where can we get information on these plants. And for a variety of reasons, we then started with the Chinese pharmacopoeia. The Chinese pharmacopoeia is a legally binding document in the People's Republic of China. And actually, Lin Ru was already involved at this stage, the student I mentioned. And the idea was to try to understand which of these plants potentially could be of interest. Now you'll say, can't be a big thing, but the Chinese pharmacopoeia has a very large body of information on medicinal plants, and I'll come to this in a moment. Aside from the Chinese pharmacopoeia, we looked at a series of other sources. One are plants from high mountain regions in the Himalaya. The problem there has been they're difficult to source. We have a collaborative project with Panama. We got some plants from there. And we had some individual species from Europe, which were quite easy to get. And I should also highlight, we have a forthcoming ongoing project, which is not part of what I'm reporting here, not part of the Velux project on medicinal plants from Saudi Arabia. So this is the summary. The Chinese pharmacopoeia, and we are talking now about the 2015 edition, has 618 drugs in it which are of natural origin, most of them plant-based. This is a huge number. The European pharmacopoeia has about 200. Of these, about 530 are botanical drugs derived from plants. We didn't want to deal with insects, minerals, and all these things. Of these, 183 are used in the context of wounds and the like. And of these, 106 contain potentially light active substances. So you can see how we have narrowed down a number of species. We then looked at these 106 in far more detail and tried to assess it. And from this, we identified 10 lead species. Now, these are available commercially on Chinese markets. I'm not going to go into these details, but we mostly sourced it via these markets in China. These are some of the species we looked at, not all of them, but the core ones in terms of activity. They're not all from the Chinese pharmacopoeia. For example, Dorstenia contravierva and Senna reticulata and Mesoferum are from Panama. Others are from Europe, but the top ones are in essence coming from the Chinese pharmacopoeia. So our experimental design, we first tried to get a UV vis spectrum, then developed a simple HPLC profile, and then we went for an HPLC quantification of photoactive substances. We also did a series of in vitro assays. There are two types. One sort of follows the idea I described. The other one, for technical reasons, was only done without an additional light element. For the experiments on the wound model, we compared dark and light situations, trying to see whether there's any significant difference between the two. For the anti-inflammatory assays, we did not have the capabilities to run this under light-controlled conditions. These are some of the spectra. Apologies for the size, but you see some of the examples. And the main one I want to highlight here is adiantum. And you see this relatively broad spectrum of activity here in terms of light activity. Bixa aureana is a very clear peak. And if you know a little bit of the chemistry, it's very clear what's behind this. So this species then became less interesting because we already knew what was going on here. While in adiantum, we were puzzled. This one here, maybe not that prominent, not very interesting. That's why I included it here. And the other one similarly. Here's another set of plants, and there's a similar picture. Ficus is one of the ones we have worked on. Caroline Macke is still following up on this. Lobelia chinensis initially looked very promising, but for some reasons then dropped out. This one also looked quite interesting, but then dropped out. So we have these data, and based on these, we looked at some key species in more detail. I want to talk about one here, and this is Adiantum cabellus veneris, one chapter in the Rumu's PhD thesis, which was published earlier this year in Frontiers in Pharmacology, section Ethnopharmacology. And the interesting thing here is we have some information, not very strong, but some diverse uses, let's put it this way. One core criterion I forgot to mention, we always focused on plants which are easily and widely available. And if you look at Adiantum, it's a species which you'll find in Europe, in Asia, and well beyond. So there were all sorts of activities. This is the key intervention, the key pharmacological experiments we did. This is in so-called Haycat cells, and we looked there at an artificial wound. And the question is, how does the addition of different concentrations of the extract improve the effect in this setup here? And you see quite clearly that there is a narrowing of this gap highlighted by the yellow lines over time. So this is, if you want, a positive example. And this on the left-hand side is under dark conditions, and this is under light irradiation. Not always did we find an increasing effect of light, so it's not necessarily the case. And in examples where we expected it, it didn't work. In examples where we didn't expect it, it did work. So we had quite a few rather surprising outcomes. This is the work only in the, not quite in the dark, because there the problem exactly is you cannot properly work in a dark condition. On anti-inflammatory effects, but the positive message is we also see an anti-inflammatory effect. I'm not going to go into the details here, but we have a very well-developed profile here focusing on inflammatory targets relevant in the treatment of wounds. Here, particularly CLCL2 and IL-1 beta as two important examples of biological or pharmacological effects. Obviously, on the left, just to clarify, this is the active, this is the control, and here are the different concentrations. Oh, sorry. So this is the second part of this series. We looked at TNF-alpha, absolutely crucial in this context, and IL-6. Again, we have a very prominent and good profile. The challenge here is this, that we could not develop in the setup there a methodology to do the light and dark comparison, so that's one of the questions we are taking into the next step. So a quick summary of what we found. We have two papers on the background already out. They've been out for a while. And I should point out that part of the reason that these papers were developed so fast was the pandemic. So we got stuck in not being able to do lab work when we started the project. And I think the representatives of the Velox Foundation are aware of this. And recently, you had the wound healing paper. There are 3 other papers under development, and specifically one I hope to submit within the next 4 weeks. We had lots of posters and other activities. Here you see some of the ones in this context, both by the key investigator on the project, Francesca Scotti, later on Banas Khalil, and obviously Lin Ru, whom I mentioned before. Here are some further ones, and the latest one was in Portugal at 25, to just give you a few examples. So, to bring this to a close, obviously these are all in vitro studies. But I think one point we now have, we have a tremendous understanding what plants have a potential. We could obviously say we only focus on dianthrones or chlorophyll derivatives like pheophobite, but our idea really is to think about what are locally useful opportunities. We did this with crude extracts, which poses all sorts of challenges and problems in vitro. There are major issues with light standardization. There's a very interesting point Caroline Mack always comes back to, and this is that we don't know what other groups are doing. So there are lots of studies done using, for example, the scratch test, which I mentioned earlier. But we don't know how they controlled on the light situation. So I think there are some very fundamental questions where we need to bring in the control of light into these systems. But the systematic selection of plant has been a crucial aspect. We found some very important examples. I've highlighted here Adiantum, the fern, but there's a few other ones. And the modulation under light, which we observed, provides some solid preliminary evidence which we hope to take forward in a variety of ways with more funding. With this, thank you again. Thanks to the foundation or the Stiftung. I want to highlight again, this has been a collaborative link between the University of Zurich and us in London. The link to Panama was facilitated thanks to a colleague in London, Dr. Alan Heskett, and a small company who facilitated the accession to the plant material. And we had Dr. Bernd Fiebisch in the team who was behind all the anti-inflammatory work, which technically was not a part of the Velux project, but of Lin Ru's PhD. With this, thank you again, and ready to have questions.
Thank you very much, Michael Heinrich, for the brilliant and relevant presentation. Now we do have some time for questions. Yes, please, Christina. Yes, please. Do we have a mic?
Thank you so much for sharing these really interesting insights. I was wondering, normally when you have a wound and then a scar, every doctor tells you to protect that from the sun, for example, because of hyperpigmentation.
From
hyperpigmentation.
Yeah.
Now, how do you think that could be balanced in what you've just shown, where you obviously would need light on the wound and potentially also UV radiation?
Well, I think the wider issue you're asking here, how do we translate this into therapeutic benefits? And this is something we haven't tackled in this project. I have to be very clear. But there is a need to think about how we take this forward. Now, there is a pharmaceutical element, because in the end, it will not be a project which runs through the whole spiel of clinical tests. This simply is not possible. But we need to think about how can we develop local resources. And that's where I think your question comes in. How can these things be done, and what are the specific needs? So my ultimate idea is to have like a standard series of protocols and have translational approaches to implement these in different regions, like in Central America, Panama, Guatemala, Mexico, or in the Middle Eastern region, etc.
Yes, please. Yes.
Thank you for sharing these interesting results. I have a question on the use of your plant extracts, because you use plant extracts for sensitization on there. And of course, we could do this also with a specific dye, with a specific molecule on there. So can you allude a little bit, what would be the benefit using a complex plant extract mixture instead of a defined single molecular compound? Is there any specific benefit?
Well, for me, it's the primary question. The primary question is, do you have access to this pure compound? Do you have access to these resources? For me, the question here comes in. I'm fully with you that you can use hypericin as a pure compound. You can prepare ready-made preparation. But it's sort of what I said in response to the previous question. We need a strategy in areas where there is no access or where there's limited access. And there are lots of examples. Now, applying a simple antibiotic, which is a very common practice in many regions, doesn't work because it has no wound healing effect. So we need to think about a combination strategy. That's why the underlying argument here is, yes, we are very conscious that there is an opportunity with pure compounds. But is there a better solution with locally available resources? When I did my fieldwork in Mexico, one of the most popular things in the community was for people to prepare topical creams and the like. And it was something which was brought in by a variety of institutions, including the Catholic Church. What did they use? Chamomile, which is not a local resource. So if we can come up with a list of species which could be used, and we can be sure that the bioactive metabolites, the photoactive compounds are in this type of an extract, we have an opportunity to use it locally.
Yeah, thank you.
Please, there's a question up here, please. Get us in. No, a microphone is arriving. No problem. Yes, please.
Don't shout at me, please.
Yeah, no. Thank you very much, Dr. Heinrich. That was very elegant. So I was wondering, I have two questions here. So you have such a unique subset of these compounds, right, that nobody, so that now you characterize them and nobody else has access, and this is so original. So when you use the immortalized cells, the keratinocytes, and so there are some, I mean, I'm also in vitro person and I love cellular systems, but do you consider to use primary cells rather than immortalized? Because the reason I'm asking is also, my second comment is the circadian rhythm. Because pro-inflammatory cytokines that you are showing, they're hugely circadian. Mm-hmm. So the timing also of this experiment, so I know that HATA keratinocytes, they are circadian. Yeah. So that, I don't know if you looked into this, because that can also hugely change the timing of where you measure the cytokines. And we measured it, the secretion of cytokines by primary fibroblast synchronized in vitro is hugely rhythmic. IL-6, for instance, has a beautiful circadian rhythm. So yeah, that was the question, basically, if you think to consider the rhythm, and if you consider for translation exactly to use the primary cells rather than the
We haven't done primary in the wound healing part. We have done it in the anti-inflammatory part. The experiments were generally run in parallel. So the cycle should have been the same, because the same set of plates which was exposed to light, or not the same, but the parallel set was used in the dark. So that was the difference. They were run in parallel, and the light had I forgot what it was, I think 20-minute exposure, and then they were all incubated together. So this part is standardized. I'm very conscious that primary cell lines would be preferential. We also, something I didn't discuss, we try to exclude polyphenolic compounds which are pan-assay interfering substance. So it was one of the exclusion criteria, because there are some major limitations, and we never really delved into quercetin, camphorol, which would have been active. So I think there are lots of controls you need to think about, and I certainly agree that that's one of them, and primary cell lines are a key next step.
Great, thank you so much.
Oh, up here. Sorry, I have the mic.
Who's next, please? Yes,
Somewhere
in the
back
back,
there, I
please.
see
Yeah.
someone.
Okay,
Great,
great.
please.
Yeah, thank you so much for your talk. So I was curious, in your work with traditional medicine, whether it be in China or in other countries, had you already found practices where particular plants were already being combined with light exposure? Like, let's say, using a plant on a wound and having a person spend time outside, and then were those plants then kind of in your bucket of 100 or so that were photoreactive?
There is no systematic coverage of this. I would say, obviously, the Chinese material is strictly from the Chinese pharmacopoeia. So it's a literature-based, and there are some reasons why we use the Chinese pharmacopoeia. There is some anecdotal evidence that certain plants are being used in the context of exposing the affected area afterwards to sunlight. A good example is St. John's wort in Europe, where this is the case, and also the preparation of St. John's wort involves daylight. So there are some examples. The problem we have is that in most reports on traditional preparations, these details get lost. So it's something we don't know whether it's happening or not. And that makes it very difficult to assess it on a larger scale. In my own experience, I have to say, I have no concrete example from the work I did and from the work we did in Mexico and in parts of Guatemala with the Chortí, where there is this type of a practice. Maybe Monica has something about the Petén area, but I don't have anything I could directly tell you from this region.
There is a question over here on the left-hand side, please, yes. Yes, even two questions, great. We have time for
Just
both.
very quickly, I noticed these are mostly methanolic extracts, and the traditional peoples I've worked with around the world often chew for example, the fern, which brings out, compounds from the enzymes, isothiocyanates, and actually that's the activity. Did you look at a water extract versus a methanolic extract in the work?
The problem is more difficult, Mike, because we also obviously mostly use the dried material. And the dried material is not the traditional one. There are exceptions, because there are some examples where you actually apply, I know it from Tithonia diversifolia, you apply the powder-dried leaves on the wound. So I'm afraid we needed a standardized process. For Nagoya reasons, the material from Panama was extracted in Panama, so we had no control over this. And they decided they didn't want to do what we wanted, so we had to go with this. For the Chinese material, it's all dried material. It wasn't clear what was the best solution there, so we went for a standardized protocol.
I just wonder you could go in any plant store and buy fresh Adiantum anywhere in any city.
I know people who have worked with, in the broadest sense, cultivars and cultivated species. And they didn't find them to be as active, it was in a different setup, antimicrobial activity, as they had hoped for. So I didn't want to go down this route. Yeah. But they were ultimately, the origin of these plants were, for Adiantum, were plants from the ornamental trade, but then grown outside.
Thank you.
Was there one more question? Yes,
One more.
please.
Actually, yes, your opinion. I'm really excited to see your research because, as you know, we couldn't ship you any of the plants we did research on for 4 years in Guatemala. And I'm looking at Big Saurayana. The traditional systematicity with which is used is not replicated in the lab. You already said for many reasons you couldn't get the fresh material. But as a reflection for our own community of researchers, there's usually this idea to ship away the compounds or the medicines to be studied in lab settings, and yet we are saying the usefulness of these compounds is for local use when there's nothing else, to have a very simple water diluted compound, or even with kusha, for alcohol, a traditional drink used by the elders. So there's all of these processes to when you cut it in the morning, when you apply it. And I would like your opinion as a scientist, how do you see the potential of rather creating the capacity in the countries? Because if regulations don't allow to export, it's for me, it's kind of sad to see that you had to get a dry plant from Costa Rica. And could we have like a daylight lab in Central America where you guys come and we do the research locally? Couldn't we advance a lot of research with the indigenous communities side by side to not lose all of these traditional? I know this is no longer a question, but I really would like your opinion, because I know the point needs to be made, I think.
Well, the point needs to be made, and I'm fully with you, and I'm fully skeptical that it works. But a very simple reminder, we are talking about Switzerland, UK, and Germany. These are 3 countries, and we went to do this because we have a specialist expertise. And I made that point in the beginning. Now, building up such a complex expertise anywhere is a problematic task and non-achievable. I think we need a better infrastructure in a place like Panama, Guatemala, Mexico, no doubt. Mexico actually has some very good pharmacology labs, and we could have done it. The reason why, in the end, it doesn't work, that we come back to this issue of export and import of plant materials. And that's why we ended up with commercial material from the Chinese pharmacopoeia. So I think the first thing I would like to see is different mechanisms of collaboration, which also enables building up the capacity locally. And that's where I see there's a big gap. We need a much better development of local capacities. And in Panama, that's certainly the case in terms of the extraction. So long term, I really hope it works, but at the same time, I'm very conscious. That's the other thing we need to see. Currently, medicinal plant research in Europe is tiny. 80% of the literature comes out of China in this field. We need to be very conscious of this. A lot of this with material which is not originally Chinese. So there is another driver here which is very different from what we just discussed here.
Thank you so much. That was a very good outlook. Also, thank you to all of you for all your questions and this inspiring group discussion we have had. Thank you very much, Michael Heinrich, for the inspiring talk, and congratulations to your brilliant work. Thank you so much. We do have a little gift for you.